Hi, welcome back to my channel. Well, in this video we'll try to utilize library AgroR again, and we will try to explore how we can make these circular charts, which are known as radar graphs in the language of library AgroR, so that we can compare different objects of comparison or different treatments or different things in terms of means, because in agricultural sciences or in forestry, comparing different groups of means is a fundamental task, especially when the null hypothesis is rejected, and when F gives us a sufficient and efficient evidence that we have to go for a post hoc analysis or a multiple comparison test. So keeping these things in view, let us start, or let us begin. We have to utilize this library, that is AgroR. I have already made a detailed video about this library in context to this experimental designs. Now, in order to make this particular plot, where we can figure out whether which groups are significantly different from each other while utilizing a particular multiple comparison test. Remember, we have different type of multiple comparison test, and in this radar graph, or in this circular plot, we'll try to explore them one by one. First, let's import this data. I'll be using a very simple data set which pertains to one-way elimination of heterogeneity design, that is known as randomized complete block design. So let us import this data set. So this is the data set. We have a set of treatments, that is paclobutrazol, and one of the treatment is control. That means we are using the different concentrations of paclobutrazol, which is a growth retardant, on an apple orchards, and we have 3 replications. That means these treatments are adjusted in 3 blocks, and we have some characteristics or variables like return bloom, fruit yield, fruit retention, fruit drop, and fruit weight. So our job is to evaluate or seek whether there exists a significant difference among these different treatments or different concentrations of paclobutrazol, including this control. So let us begin. Like in other procedures, in the previous video, which was based on the basic experimental design and pictorial experiments, if you remember, we start with this argument, that is with, which evaluates an expression in a data environment, then followed by this default bracket. The first thing is that we have to write the name of the data set, that is RCBD. Then after that, the design in which we are interested. In this scenario, we are interested to perform the analysis of an randomized complete block design. So for that, this default function is DBC. Remember, for CRD it is DIC, and for LSD it is DQL, and for factorial we have different default codes. And for after that, what we have to do, we have to write the name of the treatments. Here it is paclobutrazol. Remember, R is case sensitive, so we have to be cautious about when we are writing the small or capital letters. And after that, the blocks, since in this case we have mentioned it like this as replications. Then the variable of interest on which we are interested. Suppose we are interested in retention, that is fruit retention. Then this is very important, which multiple comparison test, example I will write is mcomp. There are a lot of options here. You can see multiple comparison. By default, it can utilize Tukey HSD, and we have some options. We have LSD, we have Scott-Knott and Duncan multiple range or DMRT tests. Like if I write this, let us start with LSD. So we have a lot of options here. Now LSD is, I think, it is usually used, I can say it is a straightforward multiple comparison test, and it is used whenever we are interested to the quick comparison. But the important thing is, it is usually used whenever we have a control in our set of treatments, and the number of treatment which you are evaluating is very small. But there is a problem in this test, that it is prone to type 1 error or false positive, and does not have a control over family wise. error rate. So we have to be cautious while choosing a particular multiple comparison test. Let us press on this enter, but before this we will give a name to this whole function. For example, we'll write it like this. Okay, then after that what we will write Radargraph, then A. So we'll be having a radar plot here. You can see if I will zoom it out like this, you can see we have let's drag this camera here. So we have different concentrations of paclobutrazol. Here you can simply figure out which of the treatments are significantly different from each other, or we can say it is all these 5 treatments are significantly different from control, and they are significantly different from each other because each and every treatment is represented by a different superscript. So this is quite simple. Now let us start with another one. Here instead of LSD, what I will write Duncan. Now when we talk about Duncan's multiple range test, or normally it is known as DMRT, it does the all pairwise comparison, and it has a better control over type 1 error in comparison to LSD. So whenever we have a large number of treatments and we want to do all pairwise comparison and we have a choice between LSD and DMRT, go for DMRT. Then we will click on this DMRT. Again I will write this Radargraph A. So again we'll be having a circular plot, although there is no so much difference because the treatment size is very small in this case. Then the third one which we will use here again, that is known as Scott-Knott. Scott-Knott is actually used whenever, actually this what Scott-Knott does, it does the categorization of treatments into different groups, and it is usually used whenever the data set is complex in a way that means the variances are unequal, or there's an unequal distribution of sample size, or we can say there's an unequal number of replication. It is best suited for that. So let's press on this enter. Now again I will make a plot out of it. So again we have this type of a plot, something like we have done in the previous one. Then the last one, which is again I will recall it, I will write it like this, Tukey, Tukey, that is Tukey HSD. Now it also does all pairwise comparison. It is used whenever we have the treatments and we are interested to go for all pairwise comparison while maintaining the strong control over family wise error rate. So that is why if you will not use any function here, by default it utilizes Tukey HSD. Again we will do the same thing, and here you can see we have a certain difference in treatment 3 point this PBZ, this, if I will zoom it out like this, let us do it like this. Now if you see in previous this PBZ, this treatment it is having a superscript of A, and it is not significantly different from this because A and A, they are the same letters here. Now if we will see the previous one, what we have done in the previously, let's go here. Okay, here we have done Scott-Knott. Here you can see treatment second, that is this PB 3.75 grams and 30. They are not significantly different from each other. However, they are significant from this PBZ 4.50. Now let us see what has happened in Tukey HSD. You see both these were significantly different from this in this Scott-Knott, but here you can see this treatment 4.5 is not significantly different from this 3.7 because here you can see the superscripts are same. So the question here is, this is quite simple, it's very simple and very easy to execute and to make these radar plots. And in this we have a lot of options for multiple comparison test, because multiple comparison test plays a very important role while we are interested to make to draw conclusions about a particular experiment or design, whether the different genotypes in terms of a particular character, they are different from each other, or you are interested to evaluate a large number of genotypes or a large number of treatments in a particular design. So every multiple comparison test is unique in a sense. It is to be used in a situation, it is to be used as per the objectives of the study, as per the layout of the experiment, as per the conditions in which the experimentation is done, and as per the number of treatments. If you are small and you are interested to do the quick comparison and you have a control in your treatment, go for least significant difference. And if you have a large number of treatments and we have a choice from LST, then go for DMRT, because it's a better control over family-wise error rate in comparison to least significant difference. Now, if you have unequal variances among your different groups, or you have an unequal sample size, go for Scott-Knott. And if you have a large number of treatments and you want to have a better control over family error rise, because it actually does a strong amount of control over family error rise, then go for Tukey HSD. So all these things can be done once your F gives an indication or gives an evidence that the things are something different, in the sense that it is able to reject the hypothesis. Then only we can do the we can go for multiple comparison test or go for post hoc. So we have a lot of options in library AgroR. Either we can use the traditional way of doing the things in library AgroR by making those column charts, which are quite good also. But if you want to put your results where you can show which of the groups or which of the group of means are significantly different from each other and which of the groups are not significantly different from each other differently or in a different way, go for these radar plots. Hope you will like this video. I will give the description of these codes. I will post all these codes on the description link of this video. Thank you very much.